All right, welcome back. And now what we're going to do is we're going to use what we've learned to solve application type problems. So the first one says that a couple invests $8,000 in a bond fund. The expected yield is 4.5% and earnings are reinvested monthly. Okay, so that means the compounded, right? So they want us to use the formula right? So now what they want you to do is they want us to take the information and set up a function for this example. So in this case here, P is the $8,000 that they're investing. The R, the rate, is the 4.5, the 4.5%, but again, we want to write it as a decimal. So that's going to be 0.045. And it's compounded monthly, so that means N, which is the number of compounds per year, is going to be 12. So now what they want us to do is they want us to set this up with the information as a function for the problem. So in this case here, what we would do is we would say, okay, A of t, right? So A of t equals 8,000 times the quantity 1 plus 0.045 divided by 12 raised to the 12t. So that is our function or equation. So now, they want us to use this equation part B and say, okay, how long would it take for the money to double? Okay, and they want to round to the nearest decimal place. Okay? So how long would it take for the money to double? Okay, so what does it mean to double? Well, what does the accumulated amount have to be then? It has to be 16,000, right? If the money doubles, they go to 16,000. So we're going to set it up as 16,000 equals 8,000 times 1 plus 0.045 divided by 12 raised to the 12t power. Okay. Now, if we divide both sides, again, this is an exponential equation. So what do? We divide both sides by 8,000 to isolate the exponential. And so this is going to give us 2 is equal to, well, this becomes what? 1 point something or other. Can we, well, let's wait on that. So this is going to give us 2 is equal to 1 plus 0.045 divided by 12 raised to the 12t. Now, what we're going to do is we're going to take the log of both sides in this case, right? So we're going to use those steps for using logs to solve an exponential equation. So we're going to log of both sides. It doesn't matter which log we use, but let's use the common logs. So we'll say log of 2 is equal to the log of 1 plus 0.045 over 12 raised to the 12t power. Okay? And now, the log helps us bring the 12t out. So what we're going to end up having is log of 2 is equal to 12t times the log of 1 plus 0.045, divided by 12. Oops, we can drop that. Okay? And so now we can solve for t. So what does t end up being? Well, I'm just going to divide everything by everything else. So t ends up equaling this log of 2 all over 12 times the log of this, which is 1 plus 0.045 divided by 12. And so now we can plug that in our calculator. Let's do that. All right, so let's take log of 2 divided by 12 times the log of 1 plus 0.045 divided by 12. All right. And we get 15.4 years, approximately 15.4 years. All right. Not bad.